This is Algebra 1, it's Semester 1, and this is a third unit called Graphing Linears. Linears just is another word for lines. It's the fourth lesson called The Basics of Graphing. So this is from CreatorMathcom under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com to find it. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. I typically try to show you how to find those notes because it can be quite challenging sometimes. So this is the website name, creatormath.weebly.com. Type that into Google. You should be able to find this homepage, I hope. Here's what it looks like. You're going to look for any kind of composition book information you need. If you don't know how to do the composition book yet, you're behind, but you can catch up by going back down to this right here that says composition book, read all the directions, watch all the videos, and adhere to all the due dates and put everything where it belongs on the different pages. And if you're doing that, including the notes, you should have a 90 to 100% on your composition book. Now when it comes to notes, we're going to go to the tab of the class, or in this case the video we're making right now. There are 4 things under the tab of the class. You will find vocabulary. If you're not getting 100% on the vocabulary practices, you may not know there is a full PDF of all vocabulary we use through the school year. It is downloadable to your device and it is searchable. Just Google how do I search a PDF on whatever type of device you're using. It is a little bit different for each device. You will also find notes, problem sets, and the videos we make here on how to do the problem sets. So now we're going to scroll to the semester for which this lesson is for. In this case it's here. So this is the entire table of contents for this semester. This should have been written by you in full on pages 2 through 6 of your composition book. If you haven't done that already, please stop this video and go ahead and do that. You're going to follow the directions from the prior page we were just on. Just watch the videos on how to number the pages of your comp book and how to put in the different aspects, and videos on the completed comp books that have gotten A's in the past. Alright, so we're going to find this unit. So it's not that one, not that one. Here we go, right here. Here's the unit, Graphing Linears. These are all the different lessons within the unit. We are on number 4 right now, so we're going to look at this one specifically. This is the basics of graphing. Here are the page numbers upon which these notes will go. Please don't take this video's word for it, but go back and find the original table of contents at the time you're looking at this. Those page numbers maybe, probably, could have changed. The notes are here. We'll open those in a second. This is the problem set we're going to do, and the video solutions we're doing now will be linked to this right here, video solutions. When I open notes, sometimes it takes me a couple times to open them. Depending on my internet speed or whatever, I'm not sure what, to be honest with you. This will either show you a page of notes from my notebook that I do notes from, or a picture of the board. The notes from mine you can see are a little bit sloppier. You'll see some of my crossouts and things and corrections, and that's okay. You're going to take these notes. It'll help you understand how to graph. So we're going to look at the wonderfully famous, in my opinion, equation of a line, which is y equals mx plus b. M is the slope. You'll see this one has a slope of 2/3. Y and x are the two axes. X is the x-axis, y is the y-axis. So you have a slope, rise over run, and then you have a b, y equals mx plus b. The b is the y-intercept. So how do we graph? This shows you how. Start with the b. The b is 1. The y-intercept, put a point at 1, because this b right here. And you graph in this order every single time, so just practice it a few times. Then we go down to start at the point at which we just put. We put this point here at 1. Now we enter the slope. The slope in this case is to rise 2 and run 3. We rise 1, 2 and run 1, 2, 3. Here it is here. Rise 2, run 3, put another dot, and connect those dots, and now we have a graphed line that is represented by this equation. We're going to also look at Desmos.com to see how this works, just to check your work. Copy all these notes into the correct pages. It'll talk about different examples. You'll put those in, talk about different vocabulary you need to know, like y-intercept, the x-axis, the y-axis, m is the slope. What is slope? Slope is rise over run. And this is already the 4th lesson in graphing. So we've talked about a lot of this already. You're going to go back and check those other lessons prior to this. Please make sure you're going in order. That'll help you sort of build the the knowledge you need to get to the next lesson, right? So just on that note, let's quickly just glance at this. I just want to show you this first. Let's glance at the problem we were here, y equals 2/3 x plus 1. If we are to go to Desmos, there we go. There we go. So this is Desmos.com. Please make a note of this. You can use this on a regular basis. And we're just going to go here and we're going to mimic the exact equation we just were looking at. Y equals, we're going to put in 2 divided by 3 to show 2/3. We're going to move over to the right, put in an x, just like the equation. And then we said plus 1, so plus 1. All right, so let's look at the line that's graphed for us. And we are learning to graph ourselves, right? And by now a lot of you know how to graph. Some of this is review for you because you've been doing this for a couple years already. And for some of you, you forgot and or it's new, okay? So here's our point here at 1, just like we went ahead and plotted. And then we went up 1, 2. So this is 1, so we went up to 1, 2, and then we went over 1, 2, 3. Put another point here, and they pass through, the line passes through this point and this point. So when they graph it, they don't put a point in there. That was for us in our method of graphing. So you're going to have a method that you use, and you're going to check the line given this. And if we click on some of these points, it'll highlight what this is. Click it twice. This is 0, 1. And that makes sense because we went up to 1 on the y. That's why it's 1 in the right place, because it's x comma y of a coordinate location. Then if we want to go up 2 and go over to this one, we can even tap this, I believe. Come on. Maybe not. Well, I'm going to hold it, and I can't get it in exactly the right place. So it's just randomly giving me wherever my finger is, right? So can't do it on my screen at least. But in other cases, you can plot a point there and find out what that is. Okay, so that's Desmos. Please use that as your graphing. That's the notes that go in your comp book. You see how to find the right page and how to bring them up. Now let's look at the problem set. This is going to go back through some review each time and sort of warm us back up to graphing. So given the following graph, what is the coordinate location of A? So keep in mind a coordinate is x comma y. We love to confuse students in math because we also have set notation. Set notation will have either a parentheses or a bracket, a comma between two values, and a parentheses or a bracket on the right. And you can mix and match these depending on the set. Set notation and coordinate are not related, okay? There is no relationship between these. All right, they are different things, but we're going to deal with both in this lesson to kind of warm you up on what's a coordinate point and what's set notation. You're going to have to be sophisticated enough to get those vocabulary words and apply them in a reasonable fashion. All right, so first let's look at coordinate location. That deals with x value, which is on the x-axis, okay, and the y-axis. And it's so common that I don't label these every time. You can if you want. I'll do it sometimes when I'm explaining it, but I expect the student to know that the x-axis is always the horizontal axis. The y-axis is always the vertical axis. It's always that way. It is a foundational idea, and this is called the Cartesian coordinate graphing system. So let's look at A. A is here. To find this, we first go to x. We always deal with the x first because that's the independent variable. We go 1, 2 in the reverse, so that's -2. So we went -2 in the x, and then we went up on the y. 1, 2, 3, 4, 5, 6. Right? So we went back to this first, then we went up 6. 1, 2, 3, 4, 5, 6. So we have -2, 6. This is a coordinate notation format. Here it is right here, -2, 6. Let's look at B. B, we didn't go anything on the x. We're at 0. So we have 0 for x, but we did go 1, 2, 3 up on the y. So 0, 3. Let's look at C. C is right here on the x-axis, so for the y value, right, we're not going up or down on the y, so that's got to be 0, but we are going 1 to the right on the x, so we have parentheses 1, 0, and parentheses, that's the coordinate location, 1, 0. What's the location of D? So here's D here. We go x first because we do the independent variable first. And just think of it as x comma y, right? Go in alphabetical order, you guys. Don't go y first, although you will see me do that sometimes, I guess. But if you're starting out and you're confused, just stick to, let's see, it's in alphabetical order. 1, 2, 3, 4, 5 to the right. So this is 5. Then we go up how many? 1, 2 to here. So 2 up on the y. So 5, 2. That is a coordinate location. And when we talk about set notation in a minute, it'll be completely different, and you're going to have to sort of erase your brain of the one topic and switch it to the other. How about point E? Let's go on the X, 1, 2, 3, 4, 5, 6. Now in this case we're going -6 because we're going to the left. How high is it on the Y? Well, it's down 1. So we went negative, we went down. So -6, comma, -1. And again, I'm assuming that you've already graphed points at this point. If you're in Algebra 1, you've already probably graphed points in prior classes. This is just a reminder and just a warm-up. F is here, -2, -1, 2, 3, 4, 5, 6. -2, comma, -6. And notice I'm going a little bit faster and expecting you to kind of be able to count it out yourself. How about G? Here's G, 1, 2, 3. It looks like so we're 3 on the X, and we went down 1, 2, 3, 4, -4. So 3, -4. All right, now we're switching to slope. Slope is rise over run. Slope can be m, rise over run. Find a point that's at an intersection in the graph. Let's say it's this one. Did we rise? 1, good. And then we ran 1, 2. We went up and to the right. Both are positive values. So this equals 1 over 2. Looks like 1/2. Rise over run is 1/2. Or you could say 0.5. That's acceptable to say m is equal to 0.5. And when we use y equals mx plus b, right, this 0.5 goes in for the m, the y and the x stay the same, the m is the slope, 0.5, and the b is that y-intercept here at 0. So you'd say plus 0, this would be y equals 0.5x. Remember you can always go back and now do this very quickly. Just delete this out. You could either say 1/2 here or 0.5x. Bing. And there you go. Okay. All right. So don't be afraid to use Desmos.com to check your graphing, to check your slopes, and to try to figure all this out. And I remember at different times in my high school career where I would know how to graph, and then a month or two would go by and I would forget. So remember, you can always go back and use these tools like Desmos.com to remember what you already knew once. So this says, given the following graph, what is the slope? More than one answer may apply. Well, this is a negative slope because it's up and to the right, or it's up and to the left, excuse me, or down and to the right. Anything headed down this way as I go to the right is a negative slope. Right, so we can start here, and here's a point, 2 points. Let's go up, so that would be +1 would be rise, but the run is to the left, so that'd be -1. Well, that's a -1 over 1, that's a -1. So this slope is -1. Okay, that's one answer. But let's say we started here, we went down 1. That would be going down 1. So for rise, we would be going down, then run to the right, that would be positive. Well, that's again the same thing. -1 over 1 equals -1. And it better be the same thing, because no matter which way you calculate the slope, you should be getting the same answer repeatedly, even if you do it 2 different ways. What's the slope on this one? Let's start with this point. We rise 2 and run 1. 2 over 1 equals 2. It's a slope of 2. And that's all slope is, you guys. It is somehow very complicated and somehow very straightforward. And of course, this is a positive slope because we went up was positive and to the right was positive. Anytime we end up with a line this way, now we know we're going to have a negative slope somewhere in there. Go back to prior lessons where we talked about positive and negative slope. We also talked about zero slope and infinite slope, but that's in a prior lesson, I think lesson number 1 of this unit. So given the following graph, what is the slope? So this is a negative slope. It looks like we're rising 1, 2, 3, so we're going up 3, but then we're going back 1, -1, so this would be -3. You might have started this way and gone down 1, 2, 3, then that would have been a -3, then gone to the right, which would have been a +1, again, a -3. So either way you look at it, and that's what they're showing you in these two answers, a 3 over -1 or a -3 over 1, same thing. Right? We better get the same answer if we compute it 2 different ways, and computing 2 different ways is a strategy to check your answer. If I can find 1 or 2 or 3 different ways to compute something, then I can be more confident in my answer. Which is the x-axis? Oh, it's always the horizontal, you guys. Always. This one is x, this one is y. Which is the y-axis? Vertical. Always, always, always. And I do remember a point in my high school career where I was like, can you switch the axes? Horizontal is always x, vertical is always y. That is a foundational understanding that if you keep in your mind will help you sort of have something to rely on. Given the following graph, what's the y-intercept be? So we have this idea of where does the graph cross the y-axis? Right here it's at 0. Y equals 0 right here. It equals -1 here, +1 here, 2, -2. This is the y-axis vertical. Where is the y-intercept? That's where it crosses at 0. So the y-intercept is 0. And we want to keep looking at b because we use y equals mx plus b. We really want to start focusing on this idea of what b is in that wonderful equation. And I kind of wish they had just written y equals slope x plus y-intercept. It'd be a longer formula, but it would be a lot easier for students to go, oh, I just put a slope here in front of the x, and oh, I just find out what the y-intercept is and put that after the addition right here. That would be a better formula in my mind because it explains more about what these parts are. Okay, given the following graph, what is the y-intercept be? This one cuts through 0, 2, y equals 0, so same thing. Looks like they might be giving us some more y-intercepts. They are. What's the y-intercept here? Okay, so it crosses right here. This is it. Y equals -2 at this point. So the y-intercept is -2. Y-intercept. Intercept means cross, right? I always think of an interception in football where the path of the ball and the path of the player from the other team coincide and they cross each other and that player catches the ball and now the ball turns over to the other team, right? An interception. That may help you to remember what b is or what a y-intercept is. Okay, so what's the y-intercept here? It crosses at 1, 2, 3, y equals 3. That's the y-intercept. All right, that means b equals 3 also. So when I start to build the slope-intercept formula, which, imagine that, what is the equation? Y equals mx plus b called. So this thing, y equals mx plus b, our wonderful slope-intercept formula. Why is it called slope-intercept? Because it's got a slope, m is the slope, and b is the y-intercept. So they literally call this intercept. They literally call this the slope-intercept equation of a line. They name it for exactly what it is. So if somebody says to you, find the slope-intercept equation, your brain is going to have to sort through, wait a second, it's the slope-intercept. Which equation has a slope in it and an intercept in it? It's this y equals mx plus b that they're referring to. All right, in the equation of a line, y equals mx plus b, what's m? M is the slope, you guys. Rise over run. And I always think m is for mountain, and that just helps me think of a person, you know, a little stick figure in my mind, climbing up the mountain, right? This is a slope, going up a hill. And this is a slope down the hill. There's a positive slope, there's a negative slope as they walk up and down, right? And they're always walking from left to right. That's the way we walk in math, all right? In the equation of line y equals mx plus b, what's b? B is the y-intercept. So hopefully this jogs your memory. Hopefully you can go back and say, all right, I do remember how to graph. Use Desmos.com to check. When graphing the equation y equals mx plus b, what do we do first? Always graph the y-intercept first. And maybe you can just go alphabetical in this case too, because it's a b, right? In the equation y equals mx plus b, what's your first alphabet item, right? If your first letter in the alphabet's B, do that first, you guys. Go for the y-intercept, plot that point first, right? So if I had, like we started out with, we had a 2/3 x plus 1. We graphed the 1 first here. Then from that point, we went up 2 and over 3. 1, 2, 1, 2, 3, 2 right here. Put a point, connected the 2 points. That's the graph of this one here, and we plugged it into Desmos in the beginning of this video to show you that that was true, which you should too. So please make sure you're matching up the title of the video with the problem set you're doing so that it makes a little bit more sense. This is Algebra 1, Semester 1. It's the 3rd unit called Graphing Linears, and linears is another name for lines, and it's the 4th lesson called The Basics of Graphing. It's on CreatorMathcom under the Algebra 1 tab. Hope this helps.